Hi, my name is Tatum Hardy, and this is Lab 2. In this lab, we are going to determine the amount of charge on a line of tape and the values of the electrical and gravitational forces. To determine these values, I'll first explain Lab 1 and how its results and procedure relate to the results of Lab 2, the procedure of Lab 2, the lab's overarching physical concepts, calculations of results with Python, and finally, the results, which were as follows. These values were determined by my Python code. In Lab 1, we were required to create a charged piece of tape by sticking one piece of tape onto a smooth surface and another piece on top of it, and then quickly ripping these two pieces of tape apart. We then repeated this process a second time to create two pieces of charged tape that carried the same type of charge. When these tapes were brought into contact, they repelled each other, and we were able to use this repulsion to get one line of tape to float above the other piece of tape. However, in Lab 1, we treated this charged piece of tape as a point charge instead of a line charge. Electric field calculations for a point charge differ from that of a line charge. However, you calculate the electric force with the same equation for a point charge and a line of charge. As previously discussed, the most important concept to grasp in this lab is that the calculations for the electric field of a point charge and the electric field of a line of charge are not the same, but electric force is calculated in the same way. An important concept to understand for this lab is also Newton's second law. For this experiment, the sum of the forces in the y-axis equals 0. Another important concept to understand is that air resistance cannot be ignored when the tape is moving into its equilibrium position. This concept accounts for the electrical force being slightly greater than the gravitational force because it has to overcome the oppositions of gravity and air resistance. In order to determine both the electrical and gravitational forces, I used Python. I started the code by entering physical constants, the mass of the tape strips, and the estimated net charge on one piece of tape, which was based off of physical calculations by hand. This by hand calculation solved for Q using the electric force equation, where the electric field input was for a line charge instead of a point charge. Then a trial and error method was used to modify the results so that they demonstrated the proper electrical and gravitational force interaction. From this step, I calculated electric field of a point charge and then used the subsequent function to transform it into an electric field calculation for a line charge. Then, to visually represent the line charges on the top and bottom tapes, I entered two vector quantities that showed their separation distance. To visually represent the electric field vector, I tested quantities until I found a scale that produced an arrow of similar magnitude to that of the electric force vector. Next, calculations for electric field and electric force were calculated. Electric force on the top tape due to the bottom tape was determined by adding up the forces from each GQ, or iteration length, in the bottom tape as it interacted with the top tape. The force for each GQ was determined by finding the electric field for each of these segments and then multiplying that field by the estimated charge. These values were then scaled so that the visual representation of electrical force and gravitational force were nearly the same in magnitude. Finally, the vector errors for gravitational and electric force were created, and the magnitudes of the electrical and gravitational forces were printed on the screen. When the code is run, it produces this image. The results for this lab were as follows. The charge was 7.49 times e to the negative 9th coulombs. The electrical force was 2.06452 e to the negative 3rd newtons, and the gravitational force was negative 2.0601 e to the negative 3rd newtons. These values were determined by the Python code, and they were approximations. Now, to interpret these results, we see that the gravitational and electrical forces result in a nearly zero net force in the y direction. When compared to the results for Q in Lab 1, which was 2.39 e to the negative 9th coulombs, it appears that a line of charge produces a greater Q due to the differences in the electric field calculation. However, in a lab like this, we must consider error analysis. The reason for the deviation between the magnitude values of the electrical force and the gravitational force can be attributed to improper scaling of the vectors in the Python code and other unaccounted for forces like air resistance. Thank you so much for listening. This was Lab 2.